Aloha! From the University of Hawaii at Manoa's Information and Computer Science program, I'm Mark Nelson. Today I'll report on the status of my ICS 621 Analysis of Algorithms project for the fall 2015 semester. My project is a survey of prime number sieve algorithms. Let's get to it. For this project, we're going to be analyzing several algorithms. For example, the sieve of Erastusthenes, the sieve of Sundaram, the sieve of Atkin. I'm hoping to get to the cyborg sieve and possibly the Brune sieve. This project, we're going to guarantee to do at least 4 of these sieves. Aspirationally, I hope to get to 6, and there's several others that I've seen in books that I don't have listed here. In terms of analysis, we're going to be analyzing these algorithms both analytically, and we'll be using the techniques that we've developed in the book and in class this semester to understand the computational complexity and possibly the space complexity required of these algorithms. We're also going to be doing an empirical analysis of the algorithms and comparing the analytical results, again, with the empirical results. The data that we'll be developing empirically are the usual suspects. We'll be looking at time, space, and with any luck, we'll be able to get into some kind of counting operations. I have the classes, the infrastructure necessary to be able to count really whatever it is that I want. I can count expensive operations like divisions, or I can even get into counting things like memory accesses if I need to. So I'm not too sure right now how deep into the empirical space I want to get to. Pretty much though, what I would like to do is to get in at least deep enough to validate and show some congruency with the results that we get from the analytical analysis. So I'd like to get the bad news out of the way first. At this point, I've only implemented 2 algorithms, and I haven't really settled on the last 2 algorithms, or the 2 algorithms that I'm guaranteeing that we're going to get to yet. However, the good news is that I've been to the Hamilton Library, and they have like 20 books on not just prime number theory and stuff like that, but specifically on sieving prime numbers. I've looked through quite a number of the books. I've checked out 2 of them that look promising in terms of having algorithms that are implementable, cogent enough for me to at least understand, and be able to have some chance to be able to make good on those algorithms. So the other thing that I've done is I've spent some time looking at wheel sieves, and the reason for that is that I've put a lot of energy into improving the utility of the base this code base, these base classes that I'm using for counting numbers. I have at the lowest level, I have a very interesting bitmap that is just simply able to count 1, 2, 3, 4, all the way up into the, I believe I should be able to get to the trillions. But essentially what I'll be able to do is take just about every bit of available memory that my MacBook Pro has. I should be able to get those bits to represent one number in this data structure. And then what we're going to do, and I'll talk about this a little bit later, is that each of the individual sieves will use that number slightly differently depending on what it is that they need to do to be able to perform their operations. But I've got at least this base class that knows how to count, and I've got the testing infrastructure in place to make sure that it's doing what it's supposed to be doing. So I want to report on the 2 sieves that I have fully implemented. So the first is the sieve of Eratosthenes. And in this sieve here, what I've done is, so far I haven't pushed the algorithm too much. I've analyzed 2 billion numbers, so numbers all the way up to 2 billion. And of those numbers, I found 98 million prime numbers inside that first 2 billion. The algorithm ran, I was actually shocked how quickly it ran. The whole thing executed in 18 seconds, and the size of the data structure was just 120 megs. So I'm looking forward to taking advantage of the gigabytes that I have available inside the MacBook Pro and seeing how far I can push this algorithm. In terms of analytical analysis, for this particular sieve, I plan on relying on the prime number theorem, which states that approximately the number of primes up to n, and that's represented by pi as a function of n in number theory, equals this number n divided by the natural log, not the computer science log. This is log base e of n, and this roughly approximates the number of primes. And I'll definitely be able to use this in an analytical technique to perform an amortized analysis of this algorithm. The other sieve that I've implemented is the sieve of Sundaram. I can tell you right now, this max prime tested, that's a limitation of the data structure that I'm using right now. It's not a real number. But what I have done is I've been able to find 1 billion primes with this. And the max prime tested, that number there, is data that's coming out of the system right now. The base class is underrepresenting the maximum number that it has actually tested, and I need to get that fixed. And as soon as I do, then, but hopefully that 1 billion primes sticks, and I'll be able to use this actually to extend the number of primes that this particular algorithm is finding beyond kind of the counting numbers that I would be able to get to if I was just using a 1, 2, 3, 4 type base class. This thing ran in 36 seconds. The size of the data structure was 250 megs, and it's pretty straightforward right now. In terms of the analytical analysis, I haven't decided exactly how I want to analyze this yet. I'm going to go down one of two roads. I'm either going to use the same approach that I used for the sieve of Eratosthenes, or what I'm going to do is my instincts tell me, just by looking at the algorithm as I was working on it, that I have an opportunity to use the potential method with this, and if I can come up with a good function for it, then I'm definitely going to take advantage of that. So I should know that in the next 24 or 48 hours or so. I want to get the analytical, at least get a handle on the analytical analysis before I move on to the next algorithm. Let's see. So in terms of the lessons learned so far, what it is that I have been doing, I've put a lot of work, as I've said before, into the underlying data structure. I can tell you that the process that I'm using is that I pretty much take this underlying data structure and I'm going to customize it for each of the sieves. My suspicion is that when I get to wheel sieves, what I'm going to end up doing is creating one instance of this counting structure for each, I'll use a disk drive term, each cylinder of the wheel, and so that each one of these things will count all the way around as I'm working my way through that particular wheel. So I haven't entirely decided how that's going to work, and if I need yet another class to be able to access the stabs of the wheel, but those are the sorts of things that I'm thinking about as I'm bringing up the tools that I need to implement the algorithms that I want to implement. So once I have the base classes set up and I have the ability to count the way I want to count, I implement the algorithm, and then from there I'm going to evaluate the correctness of the sieve. So I'm going to compare them against each other, and basically what I did is when I get into the large numbers, I'll compare it against data that's coming out of the sieve of Eratosthenes. I've compared that against the large prime number sets that I've received from the internet, so I've kind of got this chain of validation, and so I'm reasonably confident that sieve works, and I'll use that to compare or validate data from the other sieves before I move on. So once I've evaluated the correctness of the algorithm, I'll devise a strategy for evaluating the sieve both empirically and analytically, and then develop the data that I need and move forward. So I want to thank you very much for your time. I've basically gotten all of my other coursework done at this point, and this is the only thing that I need to finish to wrap up the semester, and I've got 7 days to get it done. So I'm very excited about that. I've got not plenty of time, but I've got enough time, I think, to do a great job, and I'm really looking forward to finishing this thing out, getting it done, and closing the books on this semester. Dr. Lim, I hope you have a great sabbatical next semester, and I'll see you in the fall of 2016. Thank you very much. Take care.